Today we're going to talk about how to solve a logarithmic equation, not just convert it into a logarithmic format. And there is a rule that we're going to need to know in order to solve, and it's not going to be provided for you, but I think that we will do enough problems throughout the rest of the unit that you will remember it by the time we get to an assessment. And it says the most efficient method, although there are others, to solve an exponential equation uses this logarithm law, which says log base b of a to the x equals x times log base b of a. In other words, the way I oftentimes denote it is I circle this x and I take that value and I write it out in front. That's what that logarithm says. If there's an exponent on that place mark at a, then we just take that exponent and we write it out in front of the logarithm. So here's how it works. When we look down here at our examples, simplify each of the following logarithmic expressions. Well, it's log of x squared. We can take this 2 and we can write it out front. So this becomes 2 log of x. Letter B, log base 3 of x to the 9. Again, all that happens here is that this exponent goes out in front of the logarithm, and now it becomes 9 times log base 3 of x. And again, when we see an exponent, what's going to happen is we're going to write that out in front of the equation. We're going to take this x, we're going to write it out here in front. This becomes x of log base 2 of 100. Once we know that rule, then we're going to use it to solve logarithmic equations. So how do we go about using this to help us solve exponential equations? For instance, we're going to solve the equation 4 to the x equals 8. Well, our first step here is to take the common log of both sides. So when we can't figure out 4 to what power equals 8, we don't have any value of 4 to what power equals 8. So what we're going to do is we're going to put a common log in front of both sides of the equation. We're going to put it in front of the 4 to the x, and we're going to put it in front of the 8. And what we're solving is we want to figure out, well, what does the exponent equal? So we can't figure it out when the variable is an exponent. We can use our logarithm law, which says that we could take this exponent and we can write it out front. And now this becomes x log of 4 equals log of 8. And what that means is it's x times the log of 4 equals log of 8. We're using a common logarithm because that's what's on the calculator. And now we can get to step 3 because it's x times the log of 4. We want to get x by itself, so we're going to divide by the log of 4. And if we divide the left side by the log of 4, then we're going to divide the right side by the log of 4. And now is the time that we're going to type this into the calculator. And notice down at the bottom it says do not round until the very end. And I did not put how much to round to. But let's pull our calculators. You do not need a fraction button to do this. We're going to do logarithm button. 1, 2, 3, 4 up on the left side. Log of 8 close that parentheses, divided by log of 4. You don't really need to close that parentheses, but I'm kind of in the habit of doing that. And enter. You get 1.5. Let's try, the beauty of the logarithm law is that it removes the variable from the exponent. This law in combination with the logarithm of base 10, we call our common logarithm, allows us to solve almost any exponential equation using our calculator. That LOG button on your calculator, whether it's a Texas Instruments, whether it's an Inspire, whether it's an out-of-date calculator, even if you have a not graphing calculator, same on every single calculator. Well, let's try one more to kind of get this in our head here. It says solve the following exponential equation for x. Round each answer to the nearest thousandth. So luckily enough on that last one, I didn't have to worry about rounding, but on this one, I'm going to have to worry a little bit more. I'm going to follow the same steps. First of all, when are we using this? We're using this because we've got a variable that's an exponent. So our first step is going to be to put common log on both sides. And our 5 to the x and our 18 aren't going to change. It's just that now they're going to have a logarithm in front of them. Second step, use the logarithm law. Take the exponent and write it out in front. So this is going to be x log 5 equals log 18. Using that logarithm property at the very top of our paper here allows us to get the exponent out of that position and into a position where we can solve. X times log of 5. So now what we can do is we can divide both sides by log of 5 in this case. And we're going to be left then with x equals, and we can type it in. So log of 18, divided by, make sure you close the parentheses on the 18, log of 5 gives us this decimal. We're going to round to the nearest thousandth, which is 3 decimal spaces. As we take a look here, 1, 2, 3. So we're going to look at the 8 here, the first 8, to determine how to round. And because 8 is 5 or higher, our answer is going to be 1.796. Now the thing is, it says off to the side here, we can check our answer. So we know what the answer is. But if you have an up-to-date calculator, it's very easy to check. Because what we can do is we can type in 5 to the x. But leave that number on your calculator to check it. But it's 5 to the, and instead of typing in 1.795888947, we can carry that answer down. In fact, actually, I think even the old calculators can do this. If you go second, and then the answer button, which is on the negative. So now it says 5 to the answer, and the answer that it's pulling is the 1.795888947. And when we press enter, it should equal 18. And it does. We can see that right now. In terms of showing your work to check your answer, essentially what you're saying is 5 to the 1.796. And the question is, does that equal 18? But we just saw that when we checked it in our calculator here. Let's try a little bit more complicated. And it's not that much more complicated, but this time our variable is an exponent, but it's got a 2 in front of it. That's the only difference. But the process is still the same. We're going to take the common log of both sides. Take a log here, take the log there. And it's 1.03 to the 2x, and log of 2. Second step, use our logarithmic property. And what's going to happen is we're going to take this 2x, we're going to bring it up front. So we end up with 2x log of 1.03 equals log of 2. And what's going to happen here is that we want to solve for x. It's just a teeny bit more complicated. But what I can recommend here is we isolate the 2x this time. So it's 2x times our logarithm. So let's divide by log of 1.03. If we divide the left side by the log of 1.03, we can divide this side also, the right side, by 1.03. And what we're left with over here is we're left with 2x equals, and let's type it in our calculator. Don't delete the value once you type it in. So again, we're typing in log of 1.03, sorry, log of 2, close the parentheses, divided by log of 1.03. And when we press enter, we get that number. Leave that number in your calculator. I'm going to write down 23.449. But I'm leaving that number in the calculator because ultimately what we're trying to do is we're trying to figure out what does x equal. So we're going to finish by dividing both sides by 2. And now all that we're going to do is we're going to take the number that's in our calculator and divide by 2. Now we round. Don't round before that. And what we end up with then is we end up with 11 points. We're going to round to the nearest thousand. So we're looking at the first 8 again, coincidentally, to determine what to do to the 4. And because 8 is 5 or higher, we're going to get 11.725. Flipping our paper, here, same idea. We solve for x, we want to round to the nearest thousand. This time our variable's got x divided by 3. But the steps are the same every single time. When we're trying to figure out what an exponent variable equals, we're going to put log in for both sides. We're not going to change. It's still going to be 9 to the x over 3. It's still going to be the log of 13. We didn't change the original value of the equation. We put logarithm in there to help us solve. And the reason that we did that is so we can use our logarithmic property, which says that we can take the exponent and we can write it out front. So now we have x over 3 times the log of 9 equals the log of 13. And I'm going to solve this in 2 steps again. Let's deal with the logarithms first. So it's x over 3 times log of 9. Let's divide both sides by log of 9. So when we divide both sides by log of 9, log of 9 cancels out over here on the left, and we're still left with x over 3. And when we type in this value, we're going to leave it in our calculator, typing in that number. So log of 13, close the parentheses, divided by log of 9, gives us that decimal, 1.167. That's what I'm going to write down. Leave that number in your calculator. And now we can finish here solving for x. It's x divided by 3. So what we want to do is we want to multiply by 3. And when we do, we'll take that number that's still in our calculator and multiply it by 3. We'll get 3.502 or so. And it actually is 3.502, because if we look at this number here, when we're rounding to the thousandth, tenths, hundredths, thousandths, so we're going to be 3 decimal places, we're looking at the 0 to determine what to do to the 2. And since it's 0 is less than 4, 3.502. Last kind of problems here. Solving each of the following expressions, use your knowledge of how you solve equations to help you. And these strategies are going to help us when we start solving exponential models in the next few days. And we're going to still round our answers to the nearest thousandth. So I want to add one word here. I know it's your equation strategies, but really the important word when we're solving is that we want to isolate. We want to isolate our variable as much as possible. We can't get that x out of the variable, out of the exponent position, until we do one little step. And our one little step is that we're going to start by getting it by itself, isolating it as much as possible. So this is 11 times 3 to the x. So let's get rid of that 11 by dividing both sides. And that's going to turn our problem into 3 to the x equals 4. And now that we have it in this format, we can solve, just like we've solved all of the other ones. We're going to put a logarithm in front of our problem. 3 to the x equals 4. But again, I want to stress, you want to have that 3 to the x part of the problem. You want to have that variable as isolated as possible. Now that we've got that, we can use our logarithm property, which says that we can take our exponent and we can write it out in front. So this is going to be x log 3 equals log 4. And we only need to use one step to finish this problem, because it's x times log of 3. We're going to divide by log of 3. I'm going to divide by log of 3, and we'll type it in to get our value for x. So log of 4, close the parentheses, divided by log of 3, gives us that value here, and we'll round to the nearest thousandth here momentarily. Looking at the 8 to determine what to do to the 1. Since 8 is 5 or higher, this is going to be 1.262. Again, the key to these problems is isolating. And this one's going to take more of our solving equation techniques than the last one. For starters, we're going to need to move the 3 to the other side. Because ultimately what we want to do, we want to isolate. We want to get that variable that's an exponent by itself. So this becomes 4 times 2 to the x equals 20. 17 plus 3. And we have a good start on isolating, but we're not quite finished. We need to divide both sides by 4. And when we do, the 4's cancel out and we're left with 2 to the x equals 5. And now we can finish the problem. But what's going to happen here is that we're going to have to put a logarithm in for both sides. It's the log of 2 to the x equals the log of 5. And we're going to move the x out front using our logarithm property. Carry that out front. It's going to become x. And then it's log of 2 equals log of 5. And then we can finish because it's x times log of 2. So we can divide both sides by log of 2. And that's what we need to type in to our calculator. Log of 5, close the parentheses, divided by log of 2. Gives us that value. And as we take a look at it, again, rounding to the nearest thousand, we're looking at the 9 to determine what to do to the 1. And it's 2.322 because 9 is 5 or higher. What if we were asked to solve an exponential equation with the number e in it? Well, let's give those a shot. Recall that you want to use the natural logarithm here and round each answer to the nearest thousand. Well, the natural logarithm, just a reminder, is ln. So before we even get to that point, though, we need to isolate. And when we do, we'll start by dividing both sides of the equation by 3. When we do, we get e to the negative 5x equals 3. 9 divided by 3. But by the way, you can use log, the common log on here, but because it is an e, we tend to use the natural logarithm, which is the ln. It's going to be a natural log of e to the negative 5x equals the natural log of 3. But again, make sure that you isolate. Well, next step, use our logarithmic property. And our logarithmic property says to take this negative 5x, our exponent, and bring it out front. So this is going to be negative 5x times the natural log of e equals the natural log of 3. And what we do, just like we did before, let's get rid of the logarithm part first. We'll save the number in our calculator. Let's divide by the natural log of e. Divide by the natural log of e. And over here on the left side, those natural logs of e's cancel out. And we type in natural log. It's the third button from the bottom on the left. Natural log of e, I'm going to use second in the division bar, close the parentheses. If your calculator automatically pulls up an exponent, make it e to the first power, divided by, and I typed it in wrong, so let's try that one more time. So natural log of 3, close the parentheses, divided by natural log of e. Again, I'm going to go second in division bar, just to use a plain e. But if you need to, if you've got an exponent, make it an exponent of 1. And it gives us that number here. 1.098 is what I'm going to write down. But then we're going to finish by dividing by -5. Don't get rid of that number in your calculator. We're just going to type in divided by -5 to get our value here. Divide by 5, and we can round at the end. So we're going to look at the 7 to determine what to round to. What happens is that the 7 is going to round that 9 up to 0. In fact, it's rounding 19, the 9, up to 20. So this is really going to end up to be 0.220.